Hello friends, welcome back to Creative Exploration with Princess Peach. I'm here, you're here. You picked my costume, so I'm Princess Peach. Welcome back, and today we're just gonna make some spooky stuff and make it come to life. As you can see, I'm coming to you from the lovely Mushroom Kingdom. And my wife made this awesome costume, so she rules. All right, everybody, welcome, and I hope y'all had a good week. A whole bunch of crazy stuff happened. You can check out the This Week in AI. I dropped this morning, if you're this afternoon, if you want to see what happened this week. Yeah, man, we got all kinds of fun stuff, and yeah, cool. So yeah, let's start out by just making some stuff in whoops, keep clicking the wrong button here. Keep making stuff in Flux. So let's do it. Let's make a Flux workflow like we always do. All right. So we're going to load a UNet. This is really hard to do with these stupid gloves on. We need a load diffusion model, a UNet loader. We're going to use Flux1 Dev. Flux1 Dev today. And await D type. We're going to do FE4M3FN. Fast mode is if you have a 4090, but I have a 3090, so we're going to just use regular mode. All right. And let's see. We're going to use a dual clip loader because it's Flux. I have a crown on. You just can't see it because of the stupid NVIDIA stuff. There it is. Can you see it? Hey, it came with a crown and everything, but the stupid NVIDIA broadcast keeps breaking it off. So, yeah. There it is. I wouldn't... you can't be Princess Peach without a crown. I'm royalty. All right, clip L Flux. So those are the settings. We're going to use the T5 XXL FP8 encoder, the clip L loader for clip, and we're going to use Flux. So it's, you want the T5, as you know, you go into the manager and hit model manager and search for T5. And it'll be the XXL encoder only, the FP8E4M3FN. All right. So download that if you don't have it already, and it'll go in there. And then when you hit this little refresh button in the corner, it'll show up in the list here, and you select it. So yeah, that's our model, that's our clip, and of course we need a VAE. So we're going to add a VAE loader. I think it's load VAE. There it is. And we're going to use the AE.SFT Flux VAE that comes, it's on with the Flux model. So yeah, if you've ever done Flux before, this is all normal to you. But if not, then yeah, go grab it from the same place. You got this, and I believe you can actually get it from the manager now too. So no big deal. All right, model clip VAE. So what do we do with the model clip and VAE? Well, we need to make text encoders. So let's make a clip text encode prompt. So this is going to be our positive prompt here. And we're going to make Control-C, Control-V. We're going to copy and paste and make a second one. Clip goes into both. So this is where we're telling our clips what we want to see in the prompt. And we're going to make this green and red so we know one is positive and one is negative. All right. And then the conditioning is going to come out to our clip. What is it? Flux. Clip text encode Flux. No, that's not it. I'll find it. One sec. Flux. Clip. Flux. Flux. Clip. Flux guidance? Yes, Flux guidance. So this is the strength of our prompts. So you want to be one of these Flux guidance nodes after the prompt. And we'll just pop one after each. There we go. And this is going to be our strength for each prompt. So we're going to add NSFW and nude into the negative prompt. And we're going to add spooky ghost coming out of an abandoned mine shaft, foggy, atmospheric, scary night. Let's try that. All right, so that's our prompt. That's our everything else. So we need one more thing, which is an empty latent image. And this is where we're going to pick the size of our canvas. So we're just going to start with 1024 by 1024 with a batch size of 1. And now we have all the things we need to add a KSampler. So the KSampler is the thing that does the diffusion magic. And as you can see, it has all the inputs for all the stuff. And the other thing we need is a VAE decoder. Because after it's done, we need to take the latent and plug it in here. So we're going to grab the VAE from our loader. We're going to grab the model from our model loader. We're going to grab the positive conditioning from the Flux guidance node. We're going to grab the negative conditioning from the Flux guidance node for negative prompt. And we're going to grab the latent image from this empty latent image. And that is everything. So we're going to do 25 steps, CFG of, I don't know, 1.5, I guess. Maybe 2. Let's try 2. Euler and beta. Denoise fully because it's just noise. And then we're going to save image. Save image. And we're going to call it Halloween ComfyUI. So we're saving it into the Halloween folder in ComfyUI. So this is a very simple Flux setup that'll get you kicking. Red, and you are green, and you are red because you're a VAE, and you are purple because you are diffusion. You're technically purple too. And you are blue. So there we go. That is a dead simple Flux setup. Bang. Let's hit it and see what happens. Yup. Speedrun Flux setup. In the new version of ComfyUI, you won't have to do any of this. You'll just click, I want to make a Flux image, and then all this stuff will come up for you. It's pretty cool. If you want to sign up for the closed beta, just go over to comfyui.org, I believe it is. Let me double check that. Yeah, comfy.org/waitlist. And you can sign up for the new ComfyUI desktop version. Go test that out. Give them your feedback. Spooky, 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 spooky images. Ooh, this is looking scary. A spooky ghost coming out of an abandoned mine shaft. Foggy, atmospheric, scary night. Ooh. Bum, 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 bum. It's really hard to type in these gloves. I don't know how Princess Peach does it all day. She probably has better gloves. These were very cheap. Like my puffy sleeves. Yeah. They look sick. All right. This is looking definitely spooky. I'm into it. So we can bring this to life with AnimateDiff if we want. So that might be a cool little pipeline. We can start with these images and then animate them and see what we get. Let's try that. Fix this freaking wig a bit. All right. Yeah, definitely. I think Peach is these days she probably works from home, IT stuff, maybe HR. Mushroom Kingdom has moved into the 21st century, so they're probably busy, packing orders and stuff, and she's got to make sure all the toads are used optimally. They probably have ML training and stuff for, where to find all the best treasure and things like that. But Peach is a real bad bitch with a machine learning algorithm. Okay, let's so we've got our little Flux workflow here. So I'm going to make a second workflow in another tab where we're going to animate. So we'll just keep going back and forth. So I'm going to go 127.001. I'm going to open up a new tab. So I got Comfy in this tab and this tab, but I don't need this workflow. I'm going to make a new blank workflow. And so we have our Flux workflow on the left here, and our oh, you guys can't see, but yeah, basically there's two tabs. So on the second tab here, we are going to add an AnimateDiff animation thing, and we're going to animate the image with IPAdapter and see what we get. So we're going to load a checkpoint. We need, it's called Realism by Stable Yogi version 4. You need any LCM model or any regular SD 1.5 model with the LCM LoRA, but I'm just going to use a straight LCM model, which doesn't require the LoRA. All right, so model will go to IPAdapter. No, yeah, we need the IPAdapter unified loader. Yeah, that one. Model to model, IPAdapter. We're going to pick the plus IPAdapter, and that's going to go to an IPAdapter ClipVision Enhancer. All right. Boop, boop. And we're going to use this enhanced version of IPAdapter because IPAdapter is only 224 by 224. So if we can increase the resolution of what it looks like, it'll actually look better. So we're going to use ClipVision Enhance. So there's a few things you got to do here with this node. That's a little different than the other IPAdapter nodes. So right click on ClipVision Enhancer, and you want to change the input here for the enhanced tiles to like an input thing, because we need to feed it a number and then do some math on that number. So we're going to do a primitive integer. That's the string. I just use these from Chris Tools. You can use whatever integer node you want. It doesn't matter. They come in lots of different node packs. So yeah. So we're gonna do a tile size of 3. So that's 3 times 224. So we need to do the math now. So I'm gonna add a simple math. Simple math? Yes, simple math node. Integer into A, so 3 is A, and A times 224. So we're multiplying our enhanced tiles number by 224, and this is going to be the resolution of the image that we're inputting. So we're going to load image. I'm going to pull up that image from that we just made. Where is it? Halloween. Okay, here's the image. Okay, and we need to resize this image to 224 times 224 times 3, because we're multiplying the thing. So yeah, we have that number. So what we need is to add an image scale node. Whoops. These gloves. All right, image scale node. Let's change them to width and height. Width and height to inputs, and we're going to grab that from here. So we're actually going to use both, because IPAdapter, this one is it only looks at a square. So we need it to, oh, this wig's falling off. Yikes. All right. Upscale center image goes to image. Hey, Pookie. My OnlyFans is that way. All right, primitive integer, simple math. Yeah. I know this is a lot of nodes and it's very confusing, but it will be worth it, I promise. IPAdapter goes from the unified loader into this. And we're not going to use an attention mask yet, but if you know me, you know I love attention masks. So we might get into that too, but we'll see. We'll see what this does first. So our enhanced tiles, we're sending it in 3. So that means 3 times 224, and that's going to be the size of the upscaled image that we're sending in. So this way, we've got our image being resized to the correct size for the IPAdapter node, and then the IPAdapter node is going to do all of its business to make the things happen. So that's good. Now we can send this into AnimateDiff. So we need an AnimateDiff loader, model to model. We need context options. So we're going to grab the standard. Let's do the looped uniform context options. Yeah, looped uniform. Yeah. Let's make a loop. And we're going to pick the AnimateLCM SD15T2V checkpoint, text to video checkpoint. We're going to select LCM greater than square root linear. All right. 1614 is good. The rest of this stuff is fine. We are just fine. Motion LoRA, all this, we're cool. Ooh, per block. This is new. To play with this in a bit. New stuff. I like to see that. All right, model. And so now we have our model. We got to go into our KSampler. Boom. And our positive and negative prompt we haven't even made yet. So let's grab our clip. Because this is a unified loader, this load checkpoint, it's actually got the clip in VAE all built in. So we can just do it from there. So let's grab our clip and add you guessed it, clip text encode. Because this is SD 1.5, we don't actually have to do all that Flux stuff. So let's just make positive and negative prompts. Clip goes to both green and red for sanity's sake. Okay, NSFW nude, thank you. And then for the prompt, we're going to say smoky, scary mineshaft. Spooky fog. And we're going to send that into the positive, send this into the negative, and we need, you guessed it, an empty latent image, and that will be, let's just do a 512 by 512 to start, and our batch size will start with 24 frames just to see how it do. And then of course we need VAE decode out of the KSampler, and our VAE goes into that. And our final node is an image combine node. Video combine node? How many times have I done this? All right, video combine node. Image out of there, and 24 frames per second. Let me zoom in here. We're going to change the format to H264 MP4, CRF of 13, and we're going to save the output, and we're going to save it in Halloween and ADiff. So we got ComfyUIs and ADiffs all in the same folder. Wow, scary, spooky. All right, we ain't scared of no nodes. All right, so you are cyan, you are light blue, purple. We're gonna go red and blue. Are you blue? Blue. Okay, and then you guys can be, well, technically only you're green. You're blue and you're purple. There's method to this. I promise. I promise. I promise. All right, so our clip. We need that. We need this. We need that. We need this, and then we need this. So this is our IPAdapter stack. This is our prompt. And that's diff. It's our KSampler. And our video combine. And we are good to go. So this is a dead simple AnimateDiff setup that should do stuff. So let's change it to 11 steps because it's LCM. CFG of 2. Sampler, we're going to stay on Euler, and we're going to set the schedule to beta. And randomizing the seed is fine because we're not doing any upscaling. You're good to go. Okay. So, try it. See if I set it up. I should have got peach flavored crush for the stream. I don't think we have that in Canada. Well, this is looking cool already. Wish you guys could see the crown. That's a bummer. Whoop. I'm gonna take it off because it keeps falling off. Unacceptable. Whoa. Okay. Definitely spooky. So let's look at it. What are some ways we can increase the quality? Well, we can do a second pass. We can... I don't know. It's pretty cool already, but you can see it's got some gobbly gooblies. So let's try a few things. Let's add a model. Let's add a LoRA loader. Model only. We don't need the clip, just the model. And I'm going to load the V3 SD15 adapter. So this this model is in the manager. V3 SD15 adapter. I find it smooths out LCM animation when you use it. It's not necessary, but it is good. Not always, but sometimes. Just keep thinking the wig's gonna fall off. All right, cool. So, ClipVision Enhancer, smoky, scary mineshaft, spooky fog, out of my face hair. I could never have long hair. I don't know how you ladies do it. Congratulations. I could never. I like having a little buzz cut. Although I'm sure your hair doesn't feel like dollar store dog hair, so could be different. So let's see if this LoRA loader just cleans it up just using this. Probably won't, but it's worth a shot. Basically, I'm trying to get rid of some of this, like, you see this sort of crappy looking pixelated bloop. It just doesn't look as good as it could. Okay, we got 2 moons. 2 moons. Okay, let's try 896 by 896 and see if it looks better. Like 1.5-ish the size. Well, I guess that's 768, but whatever. Let's try it. We're just doing 24 frames, so it'll take about as long as a Flux run. I managed to get Blue Moon stuck in my head. Try and move this a bit so you guys can see better. Ticker fell off. There we go. All right. There we go. Hopefully you can see more of the window now. Happy Halloween. You ever streamed in a Princess Peach costume? Nah, probably not. Now we got 3 moons. Everything we do just adds more moons. So here's what we're running into now with SD 1.5, because we're pushing from 512 to 896. So we're getting a whole bunch of extra subjects and stuff like that, because like SD 1.5 was never really meant to go outside the bounds of 512. So it like does all this weird extra subjecting stuff. So there's actually a few ways to deal with this. way I usually deal with it if I don't have ControlNet involved is I'll use what's it called? Come on, brain. Scale. Kohya Deep Shrink. There it is. I knew my brain would work. Deep Shrink. So yeah, patch model add downscale. Kohya Deep Shrink. So this node helps with a latent image if it's larger than 512 by 512 rescale itself so that it makes sense to the model, and then it can sort of like do its thing. So we're just going to pop this right in here, right at the end, right before the KSampler, and we're going to see if it does anything to make this animation more or less moons. Have, you know, one moon. That would be ideal. Yeah, my wig is on too tight. The other thing we could do is a spooky dancer. We could try and turn a dancer spooky. That might be kind of fun. Do, do, do. Do, 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 do. I would have had a guest, but I can't wear headphones with this stupid costume. But next year I'll wear a costume where I can have headphones on, and we'll have a guest because it would have been way more fun with people. Okay, so I think we have one moon now. Maybe an extra moon up in the corner though. Okay, yeah, this is better. So we're getting more consistent stuff, but we're still getting kind of the gloobles down here and some of the other stuff. I mean, it looks better when you actually look at the preview, but it's still definitely happening. Like how to fix that, you know, the tough one, you can do more diffing, you can do upscales, you can use topaz and stuff like that, but nothing's going to dream that detail back in other than just kind of nailing it from the get-go. Let's keep trying stuff. Let's set the enhance ratio to about 0.8, and that's all good. You're fine. That's cool. 896. So we're gonna go back to 512 because 576 by 320, and we're gonna get that kicking. I'm gonna bypass the Kohya for now. We're just gonna do a quick little widescreen one at the AnimateLCM res and see how it looks. Whoa, that was trippy. Okay, let's try a jack-o'-lantern sitting on the stairs to a foreboding. How do you spell foreboding? Doesn't look right. Or to a scary castle in the forest. It is spooky and lonely, and there seems to be eyes watching you from the castle. Let's make that a wide one. So we'll do 1344 by 768. All right. So once this animation's done, oh, it is done. Yeah. Okay, that's cool. This would upscale nicely. So let's go with this workflow. Let's try the jack-o'-lantern image. So going back and forth between these two is going to be the slowest part because you got to like keep loading that Flux model in and out of memory. So probably best to make all your Flux images first and then start diffing them. But if you want to, you know, it doesn't matter. It's just ways to make it more, you know, optimized. Oh, that's cool. Yeah, that's going to be a good one. Nice. I can't even use my touchpad on my laptop with this stupid gloves on. I don't know how Princess Peach does it, man. She probably has people that handle this kind of stuff. You know, like Toads. Interns. Wow, that is really cool. Flux is such a banger of a model, man. Awesome. Awesome. Let's load that image. We're going to say scary jack-o'-lantern in front of a castle. Actually, one thing we can do is we can make the prompt this image by adding a Florence 2 node. So let's add a Florence 2 run node. And we're going to add a Florence model download and load node. We're going to use the Cog Florence 2.2 large model. Large, and we're going to grab the image from here. So basically, we're using Florence to make a caption from this image, and we're going to use that as our prompt. So I'm going to convert the prompt to an input. We're going to grab the caption and plug it in there. We're also going to pull out a show text so we can see what the caption is, because I'm curious. All right, so caption goes there, and then this is going to tell us in here what the caption is, and you can like pass a string through if you want, or you can just go out twice from the caption, whatever makes you feel good. All right, so let's move you guys down here, pop the caption, I guess, here. Yeah, like so, like that, I guess. Hey, make you green. You guys are brown. Always make the LLM nodes brown. I don't know why. Okay, and ClipVision Enhancer. Diff. Yeah, hit it. So now it's going to look at the Cog Florence 2 model. It's going to look at this image, and it's going to caption the image for us. It's going to spit that caption in here fully. How do you show the image progression in the KSampler? That should be on by default, but if not, you can. There's a little gear on the Q bar on yours, but when you have it in this mode, the little gear is that's a good. Oh, it's down here. This little gear here down here, and that's going to bring up your settings. And then in here, you want to look at the. Sorry, it's in the manager settings. My bad. In the manager, there's a preview method. It'll either be auto, TSD, or latent RGB, or none. So latent to RGB is the fastest. TAESD looks better, but it's slightly slower. But you know, whatever. And then yeah, so latent to RGB is the fastest one, and cool. So yay, nice, cool. All right. One thing I'm going to do is add the sample settings, and we're going to try a different type of noise and see if that makes it look cooler or not. Pale blue. So we're going to try the FreeNoise option instead of default and see if it looks cooler or not. It might not. It might. It might. No, not much better. I'm trying to avoid is this just sort of back and forth thing that it's doing, where it's sort of picking a. You know what? Let's try a motion, LoRA. You can go get these off of Civitai or whatever. I'm gonna use one of mine. Let's try. Oh, I don't know. Floating upward. I'm gonna try my spreading out one, and we're gonna set it to like 0.6-ish. And we're going to set the motion on the animate. Oh, wait. Oh, the AnimateDiff loader changed a bit. I'm going to add a scale multival. So this is going to be the sort of scale for our motion. Okay, and pale blue. Good lord. Okay, so that should do it. So this will hopefully give us a slightly different animation with the custom motion LoRA. So it's very static. I'd like to avoid the staticity of it. We are only giving it 24 frames though. Oh, that's pretty cool. Let's do a longer run and see if we can get some cool animation out of this. So let's try 64 frames. That'll be 4 context windows, so we'll see what happens if we can get some kind of motion that happens over time. Render, render, render. You can always rent a GPU to do the Flux stuff and do the ADIF locally, or do the Flux stuff locally and run the ADIF on the cloud, you know, if you want to do this stuff at the exact same time. But going back and forth and having patience isn't the worst thing in the world. Let's see what we got here. Probably not going to use the 32 frame motion LoRA for this. I'm already getting some artifacting I don't like. Here we go. That's kind of cool. You can try the 32 frame motion LoRA if you want. CSETI. So there's a 32 frame motion LoRA. You can go grab it by CSETI. Search for CSETI. There's general motion LoRA 32 frame. Yep. Oh, there's a newer one. Oh, we'll try the old one. And then you can set your context length to 32 and your context overlap to 8. And this will make it even, make the context last even longer. So let's try that. I think we should try to make a spooky dancer instead of a ambient ADIF animation, because it'll probably be cooler results. Out of my face. Out of my face. Out of my eyes. Yeah, see, that 32 frame motion LoRA is cool, but it's a lot more like relaxed than the other ones. But it's cool. He's cool. He's cool. All right, let's adjust this a bit. We're going to get rid of this ClipVision stuff. We're going to keep the ADIF stuff, and we're going to reroute the way we're masking. So we're going to use the BiRefNet 2 nodes, BiRefNet 2 by LLDACING. ComfyUI BiRefNet 2, they are good and they work. So that's why we're going to use them. Okay. Let's use them. BiRefNet. Oh, we got it. So we're going to use the BiRefNet 2 auto download BiRefNet model, and that's we're going to use the matting one. That's my favorite one so far that I've tried. And then we're going to use the remove background by BiRefNet node. We're going to use this to pull a dancer out of a video and use that mask to do some cool stuff. So let's do it. All right, load video. And then I need to load up one of these guys. Let's do this guy. We're going to skip first frames to about 240, and we're going to load about 96 frames. That's about where I want it. Yeah, 230. 230. Nah, perfect. All right. Make sure my desktop audio is off so I don't immediately get skaglonked. All right, so BiRefNet, remove background. So let's have a look at what we're making here. Video combine. MP4, CRF of 13, don't save. So this is just going to show us what we're doing here. And then this mask, we're going to convert mask to image, and we're going to do the same thing here so we can see what the mask is doing. Bloop, 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 and then you'll get an idea of what we're up to here. 13 false. Okay, so boop, 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 bonk. All right, and you. So what we're doing here is we are going to take this video and we're going to use BiRefNet to mask out the subject from the background. And then we're going to use that to make a IPAdapter animation. So let me grab these nodes, and I'm just going to put them in a new Comfy window so you can see what these do exactly, and then we'll go on from there. So let's workflow new blank and paste. Okay, so this is going to go through and it's going to look at these frames from the video, these 96 frames. It's going to pass them through the BiRefNet background remover, and then it's going to give us both the video with the background removed and the mask that it used to remove the background. So with those two things, we can make some cool stuff in AnimateDiff. Let's let BiRefNet do its business. It's a little slower than it used to be. I think the algorithm's a little better, but that's fine. I'd rather have a better mask if it takes a little longer than have a crappy mask fast. Of course, that's situational. If you're trying to do real-time diffusion, obviously faster is better. So yeah, you just got to decide what your use case is and what you need it for. Yeah, man. So there. So now that we have this, we can do stuff with it. That's pretty good mask, and we didn't even have to buy After Effects, so that's kind of sick. All right, so we have those two, and that's out of these two. So what are we gonna do with those? Well, remember how I said AnimateDiff has an attention mask? Well, what if we want AnimateDiff to pay attention to the stuff in that mask and then pay attention to the stuff in other masks? Well, we can absolutely do that. Let's yank you over here. We're going to need 3 IPAdapter nodes, IPAdapter advanced nodes, okay? 1, 2, and 3. And we're going to do 3 different masks. We're going to create a shape mask. And that shape mask is going to grab the frame width and height, frame width and frame height to turn those into inputs. Grab those from your, well, I'm going to have to make 2 primitive nodes. Primitive integer. So we need to set the width and height in multiple places. So we're just going to do that here. 576. Actually, 320 by 576 because it's a tall video. So we're going to swap it. Okay. Empty latent image. We're going to convert the width and height to inputs. And then that's right. We're going to plug them width and height. and width and height. Oh my God, I just noticed something. Oh, we don't have to convert inputs anymore. You can just drag them on and there's a little dot. That is, ooh, that is lovely. It'll take me a few months to remember to do that, but YOLO. Okay, so we have our width and height. Now we can do some fancy math here if we want. So we're going to, because we can. Simple math. All right, we need 2 of these nodes. Okay, A divided by 2 and A divided by 2. The reason we're doing this is we want the center point of both of these resolutions to be location X and location Y. Okay, so we're dividing 320 by 2, which gives us the middle of the center, and that's where we're placing our shape mask. Same thing with the height. So our width and our height here, height here. Okay. The number of frames is actually going to be another integer. So we're going to say 64 for now. Plug that into the batch size of the empty latent image and also plug it into the amount of frames. I don't even need that anymore. Just drag it on. Drag that into the amount of frames for the run. So that's how many frames we have. That's our width and that's our height. That's our width and that's our height. Math. Frames. Okay, and then our shape mask here. This is going to be a square. And so what all I'm doing here is I'm going to make the width of the shape the width of our animation. Oop, width, frame, shape width. And then the height. Actually, I'm going to uncheck location Y. I'm going to turn you back into a widget because I need to adjust you manually, and I'll explain why in just a second. Okay. Grow we're going to leave alone. Grows for animating. The shape height, we're going to set it to about, is this mouse 576 high? So let's go 320. Okay. We're making a ground and a ceiling, or at least a floor and a background. Okay. So we are making these masks here. So let's convert mask to image and pop one of these little video combines down here. Doop. And we also need another one for the inverted mask. Yeah, man. And then so you, and then need another one, and it goes here. So between these and these, trying to figure out the not dumb place to put this stuff. That should be good. All right, so between yeah, that should be fine. So now we have these 4 masks. Okay, so we have the floor, the background, and the person. So we need to combine all these into colors because we need to split these colors apart into a combined mask. So I need to take them all, layer them together in Comfy, and then split them apart with colors, which is not that hard. It sounds harder than it is. So our first mask, we need to add a blend image blend. Let me find it. Image blend. We want the one with blend mode multiply. Yeah. So blend factor of 1, blend mode multiply, and we're going to multiply the first mask with the color red by doing an image blank. And the width and height are from our width and height of the project. This way we only ever have to set our width and height in one place, right? Whenever we want to make changes, you know. And then we need to actually repeat this image by the frame count, right? So we got to plug our little amount of frames, 64, into the amount image, and then we're going to multiply that. So what this is going to end up spitting out is a red mask. That is the ground. Okay. And we need Control-Shift-V to paste with connections. And we're going to grab this mask for the green one. So we got red, we got green. So we got red, green. And we need a blue mask, which is the person. So let's do that as well. This person mask here, here it is, the mask. Okay. So this one, we are going to add a different node. It's called Image Composite Masked. And we're going to take, so we need image blend, these two together. This is all just compositing. This will make sense when you see, we'll walk back through everything we're doing here. I believe it's screen, but don't quote me, and we'll find out in a minute if I'm totally wrong. So this will become our destination, and then our source will be this mask run through a blue filter. Another thing I need to do, I just realized, is resize this mask to the size of the project, or we're going to run into problems. So I need image scale, upscale image. Change width and height to inputs. We don't need to do this anymore. This is just old school. All right, so plug this in here, plug it through. So now we're rescaling it to the width and height of the project. Sick. All right. So our mask will now resize to the right size as it goes. Doop, doop, doop. Do that thing, do that thing. All right. So our source is now going to be a blue version of this mask. So it is not unlike these. We need another stack like this. We're going to grab that width and height. We're going to make it blue instead of green. And we're just stacking all this stuff into the same mask. So let's grab our image from this guy, and then the amount is right. That's right. Your image blank is going into 1. Image blank is going into 1. You're blending, and then so your blue, the blue source that's going on top of the destination, and the mask is the mask of the person, right? Who knows? If I did all this right, we'll see, and then if not, we'll debug it. So let's run it to get it to do all this stuff. And see how it goes. You can do the KSampler first. God damn. All right. I should have put all this stuff in a second project before I ran this, but we'll just wait for this diff run to finish. It won't take that long. Famous last words. There we go. Oh, that looks cool. Nice. All right. But now it's doing all the business. So I screwed up this part already. But let's keep going. See what it does. See what it do. Okay. Okay, now we're doing the masking. I screwed up the shape mask, but we can fix that. That's an easy fix. Basically, it should go all the way up, not just, you know, be in the middle. Come on, baby. Okay, we got our red mask, we got our green mask. Now, hopefully we're mixing our red and green masks together. But we're not, because I screwed something up. This blend and this blend are mad at each other because why? Really? Are they different resolutions? They shouldn't be. Okay. Well, this will give me a chance to fix the mask. So the mask shape height is going to have to be taller. Let's do 512 or let's do 600 maybe. And hopefully that give our dude a floor to stand on. Oh, it's mostly floor. So then our location Y, we can move that. I think a lower value is higher, I think. Let's try 100. Oh, wait. Oh, wait. I know what's wrong. We don't need these repeat image batches because they're already repeated. I think I over engineered my solution here. There we go. That's a ground. See what we're doing? We're building a ground and a top. Yeah. Oh, we're doing a KSampler before the final bit? That's fun. This is why you shouldn't build these workflows inside of an existing one, because this is really annoying. Bypass the KSampler. See if we can do this last bit here. You know, Florence. Okay, so we want a blue dancer on a green floor with a red background. If this worked. Though I think that image blend mode might... Yeah, that's right. Hey, we did the thing. Okay, so the reason I wanted to do this was because now we can take this mask, which is perfectly segmented, separate it into these three colors and feed it into these three IPAdapters here as three different attention masks and get the party running. Okay, so let's try that. Let's take this final output that we needed here and make it the what is it, the RGB mask from RGB CMYBW. This one. Okay. Plug that in here. And now we got these mask outputs for the colors in our mask. So if you got a red, green, blue mask, you can just make that in anything. Take it in here, use this node and plug these in. So grab our mask from RGB and go red into the first one, green into the second one, blue into the third one. Okay. Easy peasy. So now we need the IPAdapter unified. All right, let's change that to phase. No, just regular plus. And let's feed the model in. Boop. Model goes through all the IPAdapter nodes out to our AnimateDiff loader. Yeah. Oh, we missed the LoRA. Never miss the LoRA. Okay, so that should do it. Now, IPAdapter goes into all three. Boop, IPAdapter. We've got our mask, we've got our IPAdapters. So the last thing we need to do is give our IPAdapters images to look at. So let's do image and image. Okay, so we need a ground. Type ground in and pick an image. Perfect. Okay, pop that on the old desktop. All right, and then we need sky. Just need any old picture of the sky. Hey, we like free pick. We like free pick. All right. And let's try astronaut. Oh, let's try spooky Frankenstein. I'm gonna try to get Frankenstein style monster. Maybe. You kind of need a full body Frankenstein. Frankenstein full body shot. That might work. Ooh, I like that. Let's try that. All right, cool. So we got our 3 images. Obviously, this is not for commercial purposes. We're just trying stuff. So we're going to go with the ground, which was this one. And we're going to go with the sky, which was this one. And then our Frankenstein. Where are you, bud? There we go. So green ground, red sky, blue Frankenstein. Yeah? Yeah? Yeah. Colors. All right, cool. Cool. Let's see what it do. Well, this friggin' got out of hand. All right, cool. Let's hit it. All this just to say, like, you can wire this stuff up any way you like. Late to the party? No, you're good. Okay, so one thing I forgot to do was add ControlNet. So we have IPAdapter splitting things, which is great, but it doesn't really understand the form of what it's going to make here. So our Frankenstein is probably going to look very stupid. So while this is rendering, I am going to add ControlNet. Apply ControlNet Advanced. That's the one. Okay. ControlNet is on the conditioning stack, so we're going to pass our positive and negative conditioning through. And then ControlNet onto here. And we want to use, we're going to use OpenPose for now to get the pose of the person. Yeah, see, it understands that we're trying to split these things into segments, but because it doesn't have ControlNet, it doesn't really understand what exactly we're trying to do. So let's try and help it with ControlNet. So the image, we're actually going to use the DWPose estimator, and we're going to change this to the Torch script version. Okay. We're going to grab this from our upscaled image. So this is going to calculate the DWPose, apply ControlNet to it, and hopefully we'll get a dancer, and we can see what this does by grabbing one of these video combines here. Plopping that down there as a preview. You notice on the previews I have save output off because you don't want to waste hard drive space on these previews. They're just for temporary viewing. Okay. So that's ControlNet. Let's make you yellow. You bleh. Bleh. Okay. So hopefully get better stuff. So now it's estimating the pose of the dancer. Slowly. There it goes. If your DWPose is going very slowly, fix it, because it should go this fast. It shouldn't be. There we go. There's a little dancer. Hey. So now it's gonna apply this hopefully to the animation using ControlNet. Full strength. Yeah, see, now that it knows where the body is, it's much better at picking out the masks in the IPAdapter. The other thing we can do is we can look at the masks that are coming out of here to make sure that we're getting a good result into the IPAdapters, because yeah, you never know unless you preview. You can guess, but it's, you know, sometimes it ain't right. So let's see. Red, green, blue, and then we're going to pop one of these little video combines underneath each of these. Yeah, it looks like we're good. It looks like it works, but you might as well. This is good to do best practices stuff. Boop, and boop, and then boop. So, yeah, there we go. Man, we really went all out on this. So we're actually gonna, instead of describing this scene, which is causing all kinds of problems, I'm actually gonna describe the subject into our Florence thing instead of this image. So we can get rid of this now. We don't need it anymore. And yeah, let's try that. So once this stuff's all working, you don't need these previews anymore. So you can go in and remove them and then clean all this up so that it's like a, yeah, like a tight little window thing so you can get to work. There we go. Yep, we're getting the right stuff. The right stuff. See, that's why we combine these masks, because we want to make sure the person is cut out of the other two masks, which you can't do until it's all combined. That's why there's all this nonsense to get this mask that we can composite then into these three masks. Because if you have this on top of this, then it's going to mix the dream of the ground and the feet. You know what I mean? This way it's going to leave room for the feet so that it can dream the right stuff. Yeah, that is killing it. And the next thing I'm going to add is a depth map. But we're going to do a little trick here too. So instead of DWPose estimator, I want a depth anything relative V2. Yep. But we don't want to get the room. We only want the person. But if we feed the person mask that we already have, there we go. That's starting to get good. Sick. All right. So now, mask, you're good. Mask, you're coming out of there. 1, 2, 3. Here, 1, 2, 3. Yeah. Okay. Cool. Yeah. Simple math. Simple math. Quick math. Yeah, baby. All right. So call you frame count width height, and you are width divided by 2, and you are height divided by 2. That'll help your little brain with all the annoying stuff of not knowing what anything is. All right, okay, you're good, you're good, you're good, you're good. Oh, that's good, that's fine, that's all good, you're good. So next, so the other thing you can do is ignore the prompting and just say, because we have this fully covered by IPAdapters, we don't really need this prompt. We can just say 4K high quality. And the IPAdapter should handle the rest of it. So we can get rid of this Florence stuff for now. Yeah, simplify this workflow, you know, just really simplify the hell out of it. Okay, so we'll go back to the depth thing we were doing here. So I got my depth anything, but again, I don't want the room and I don't want the blackness behind the person because that's going to come through with like this white depth map stuff in the background as it's just kind of like trying to determine the depth of nothingness. So we're going to use a similar tactic to what we used here, which is this image composite mask node to make sure that we're feeding it just the masked out depth map. So we're fine to give it a full depth map from the image upscale node from the initial footage. So it's going to do the depth map and do all the business, but then it's going to take this, we're going to make that the source, and the destination is going to be, you guessed it, an image blank. With a repeat image batch. We're going to plug the frame count into that because it needs to be the same length as the animation. All right, and then so that'll go in here. This will go through to the destination, and the mask, you guessed it, is the person dancing, which is from the BiRefNet mask. Perfect. Okay, so we can see what this looks like here by checking this. And the other cool thing is we can see 0, 0, 0. Oh yeah, and I forgot, we need the width and height from our project as the width and height for the image blank. Get that. Okay, width and height 0, 0, 0 for black. So I'll show you what the difference is, why we're doing what we're doing. Okay, so this one here is going to be what it would be without all the tinkering we just did. All right. Now we got to pass the positive and negative through like a water wheel, any of the control nets. Yep. And we're going to leave depth at 1. We'll just leave everything at 1. Gadoosh. All right. So it's going to run. Ooh, what did I miss? Image from this. Thank you. Stop. Try again. There we go. Oh yeah. So now we're calculating the depth map from the input footage, and then we're going to mask out the person from the background after the depth map is done using the mask from the person so that we get the exact person depth map and we leave the background alone. And then the one to the right here is going to show you what would happen if we didn't mask it out and why it would be problematic, because that version will just create all kinds of weird nonsense. And we also got a problem where it's not resized to the right size. What's that about? Why are you so big, bruh? Why are you so big? Depth map. Are you not going to... The mask? Yeah, that's all the right size. How come you're not the right size? Bud. All right, let's try to resize source. Try that again. It's weird. Yeah, okay, there we go. So yeah, see the difference here. We've masked the person out from all this stuff in the background, because if you run this depth map with all this, this is all gonna come in through the animation. But you really just want the depth of the person, right? not the depth of the room. So that's why we did this extra mask compositing stuff. The size at which it's coming in is strange to me, though. I don't know what that is. The source is anything, and you're coming from... should be coming from here, which is the right size. Yeah. Whatever. So we don't need that because that's just showing us what we're not using. Alright. Wow, this was just going to be a simple image making stream, and then I went all hardcore into the person masking. And then here's the part where you start playing with the ControlNet strength to get, you know, less of the input. Because right now these guys are all at 1, 1, 1, 1, 100% everywhere. Just turned him into a dude. And again, these are super low res because we're just rendering them quick for the stream. So you just start increasing the resolution to make it look better and better. But yeah, that's the basic structure, you know. We're just separating and regulating. So let's change the ControlNet strength. We're gonna leave that at 1 for the pose, but we're gonna set the strength of the depth to 0.5. We're gonna start it a little late at 0.15, and we're gonna end it around 0.6. So it's only gonna latch on 15% of the way through the run, and then stop 60% of the way through. It'll let go. And just let it dream. You know. And that should give us more of a Frankenstein monster and less of a whoever this guy is. It's just too much depth. Too much depth, maybe. And I think our ground image suffers from having clouds in it. So let's try ground earth. It's like a picture of like the ground. Ooh, that'll work. No stock photos, thanks. Just need a regular picture of dirt. That might work. Let's try that one. Oh, it's an AVIF. Great. Awesome. There we go. You an AVIF? No, you're not. All right, comfy. Get back. There we go. Not you, you. There we are. Okay, so there. Ground, background, person. If you set your CFG to 1 or like 1.3, the runs are much faster. I can't do it because I'm streaming, and sometimes it'll make nude stuff. There we go. Everything's a little still green. I don't love that. Let's get rid of the depth control net. See if we can get back to old Frankenstein here. Yeah, you know, you just drop whatever whatever footage you want in here. It'll auto mask it, auto make the background, auto do the thing. Then you just drop 3 images in and type a prompt and hit go. Easy workflow. Dead simple. There's a version of this workflow on my Patreon. If you just go sign up, it's in the resources for supporter resources. Ooh, I think I got my backgrounds backwards. I did. But nobody said anything. You guys aren't paying attention today, I swear. Alright, so I want the red mask to go into this one, and the green mask to go into this one, just for ease. So that'll be ground, sky, person. Yeah, see, it's backwards. Dancing on the sky with the ground behind him. Perfect. All right, let's try and make him dance on bark with the sky behind him. It's funny how it always turns the sky into water when you're standing on it. Do photo manipulation like a poster for Halloween? Nah. Boring. Gotta get more Frankenstein in here. Gotta get my man Franker in here. So it knows this is supposed to be Frankenstein. We're gonna crank the weight up to like 1.5. YOLO, bro. So let's try it. Okay, he's on bark. The sky is behind him, but he's not Frankenstein. Maybe this guy doesn't look enough like Frankenstein. What if we do like Frankenstein face? Will it make it like full on? Let's find out. Let's find out together. Wow. My little jewel fell over. Unacceptable. Do. Come on. Give me that Frankenstein, man. Did I forget to wire you in or something? No, you're all good. Tension mask coming from right place. Just doesn't want to give me Frankenstein. Just give me a dude in a blue suit and green suit. I guess he won't be doing the monster mash tonight. Yeah, kinda. Kinda. Well, let's try Frankenstein dancing on dancing at the beach. Wait. We could also try soft edge to try to get like more of the person in there. That works sometimes. What did I do? Hit the wrong button. We don't need the downscale. It does not want to give me Frankenstein. Just can't Frankenstein. There we go. That's pretty close. Definitely got a green suit. All right, cool. So yeah, that, I mean, this workflow is very powerful. Go ahead and rebuild that from the stream if you want. Yeah. We covered Flux image generation. We covered AnimateDiff. We covered all kinds of stuff. We covered masking in AnimateDiff. Man, we can go further and further, but I think that's actually where I'm going to leave it tonight. Good hour and a half. That was fun. If you want to continue your AnimateDiff studies and push forward, come to the Discord, come to the Patreon. There's more advanced techniques there. There's more, more powerful stuff you can use, combinations of different tools. Go back through the old streams and check them out. Thanks for hanging out with me. Thanks for being here on Halloween. And yeah, I'll be back real soon with some normal stuff, and I'll probably be wearing normal guy clothes. But who knows? Maybe I'll just be Princess Peach from now on. We'll see. But yeah, thanks everybody. This has been really fun. And yeah, dig around in Comfy and break stuff and make things, do things wrong because it's more fun than doing them right. All right, Purrs loves you. Have a great night, and many kisses from Princess Peach on out to y'all. And we'll see you next time. Bye bye, everybody.